Hi class, this is part 2 of section 5.4. We're up to example 3, so we want to graph the rational function r of x is equal to x squared plus 3x minus 10 divided by x squared plus 8x plus 15. So we'll start by factoring the denominator. So this factors to x plus 5 times x plus 3. So the domain, everything except for negative 5 and negative 3. Okay, so to determine next if we have vertical asymptotes or wholes, we need to factor the numerator. The numerator factors to x plus 5 times x minus 2. So we see that the x plus 5's cancel, so that tells us that when x is equal to negative 5, we will have a hole in the graph. We still want to figure out the y value of the hole, because the hole is an open circle on the graph. So it has both an x and a y value. So once you have your rational function in lowest terms, then what we want to do is plug in negative 5 for x in this reduced form. So that would give us negative 5 minus 2 over negative 5 plus 3. So negative 7 over negative 2. So positive 7/2. So the whole is at negative 5 7/2. Okay, so again, we have a hole in the graph because the x plus 5's canceled. To figure out the y value of the hole, plug in a negative 5 into our expression that's in lowest terms. So in this case, x minus 2 over x plus 3. Okay, vertical asymptote, that will be at x is equal to negative 3. Our horizontal asymptote is y equals 1. The degrees are the same, so we look at the ratio of leading coefficients. X-intercept. So to get the x-intercept, we will let y equal 0. If your rational function reduces, use the reduced form. So 0 is equal to x minus 2 over x plus 3. Remember, a fraction is equal to 0 when its numerator is equal to 0. Add the 2 over, so our x-intercept is 2, 0. The y-intercept, so we get this by letting x equal 0. Again, we could use the simplified form. R of 0 will get negative 2/3. Even if you went back to the original expression for this one, you'd end up with negative 10 over 15, which reduces to negative 2/3. Okay, so start off by factoring the denominator. That'll tell you the domain of your rational expression. Factor the numerator to see if anything cancels. If a factor does cancel, then you will have a hole in the graph. So we have a hole at negative 5 7/2. X equals negative 3 is our vertical asymptote. Y equals 1 is our horizontal asymptote. Okay, and then here's the reduced form of our function, and this is where the 7/2 came from. So to get the whole, we're going to plug in negative 5 into the reduced form. So negative 5 minus 2 over negative 5 plus 3, that reduces to 7/2. Okay, and then we have our x-intercepts and our y-intercept. Okay, so here's my graph. The only thing I have marked off, first of all, the y equals 1, our horizontal asymptote is marked. X equals negative 3 for the vertical asymptote. And then our x-intercept at 2, 0, y-intercept 0, negative 2/3 is our y-intercept. And now we're just going to graph the function. So our graph is again in two pieces, separated by our vertical asymptote. On the right-hand side, our graph has this horizontal asymptote, so the function has to get closer to that horizontal asymptote as x gets bigger and bigger. Cross the x-axis at 2 across the y-axis and then go down towards negative infinity. We knew that we should be crossing at 2 because if we had to give a multiplicity to this x minus 2, so multiplicity to 0 or 0 of 2, it would be 1, so our graph crosses. Okay, on the left side of our vertical asymptote, think of it as coming from that horizontal asymptote, jump over the hole, and then continue up towards infinity. Okay, so a hole in the graph is helpful because it's just like having a point on the graph. It's just that it happens to be an open circle instead of a closed circle. Okay, so a couple of things. If we talk about the limit, just to remind you guys, so the limit as x goes to -3. Okay, so we're looking here at -3. If I approach it from the left, so I'm coming at -3 from the left-hand side, we have to write an r of x here. So we see that as I approach -3 from the left, the function values are going up to positive infinity. If we approach -3 from the right-hand side, we see that our function values are going down towards negative infinity. Okay, good. So here's a graph drawn on Desmos. On a quiz or on a test, I'm not going to ask you about the limits, but I just wanted to prepare you for the homework and then also for your next math class, so you will see limits in business calculus. So example 4 now, our function is -4 divided by x cubed plus x squared minus 9x minus 9. All right, so we want to find the domain of the function. So we need to factor the denominator. This time we have 4 terms, so factor by grouping. Group the first 2 together, we can take out an x squared, and then we're left with x plus 1. Last 2, we can take out a -9, and we'd be left with x plus 1. The x plus 1's match up, which remember they have to, otherwise you made a mistake, or you can't factor it by grouping. So factor out the x plus 1, then we're left with x squared minus 9. Okay, so I'm going to come back up here to my function. When I rewrite it in the denominator, x plus 1 is good, and I'm going to write the second guy in factored form. So x minus 3 times x plus 3. And the numerator is just -4. Okay, so the domain of the function is all row numbers except for -1, and also x cannot be plus or minus 3. Okay, all 3 of those are going to be vertical asymptotes because nothing cancels, right? We only have a -4 in the numerator, so nothing is going to cancel, which tells us that there will be no holes in the graph. Okay, the horizontal asymptote. Okay, so the degree of the numerator is 0. Okay, so numbers without an x are just degree 0, except for 0, but -4 has degree 0. In the denominator, this is degree 3. So the denominator has the larger degree. So hopefully you remember, anytime that happens, it means you have a proper rational function. So the degree of the denominator is bigger than the degree of the numerator. Your horizontal asymptote will be the line y equals 0. So it's the x-axis. Okay, x-intercepts. So remember, we get to get x-intercepts, let y equal 0. And also, if you have a fraction is equal to 0 when the numerator is equal to 0. Okay, our numerator is -4, so it's never equal to 0. All right, there are no x-intercepts. Y-intercepts, let x equal 0. Plug in a 0 for the x's. I have a -4 in the numerator. 0 plus 0 minus 0 minus 9. -9 in the denominator. So positive 4/9 is our y-intercept. Okay, so again, factor the denominator. This will tell us the domain of the function. It lets us know which numbers to eliminate from the domain. Nothing canceled, so all three of these guys were vertical asymptotes. We do not have a hole in the graph. The horizontal asymptote is the line y equals 0. That is because the degree of the denominator is bigger than the degree of the numerator. We do not have an x-intercept, but the y-intercept is 0, 4/9. Okay, so let's start by putting in our vertical asymptotes. So I have one at x is equal to -1. Another one at x is equal to -3. X is equal to -3. X is equal to +3. And then the horizontal asymptote is the x-axis, or the line y is equal to 0. Y-intercept is 0, 4/9. So it's a positive value here. Okay, so graphing this one's perhaps a bit trickier. Let's start, we have, let's see, this is 1, 2, 3, 4 sections to our graph this time because we have so many vertical asymptotes. Okay, I have my y-intercept that's here, and I have to stay away from the x-axis because I don't have any x-intercepts. So that tells me that my function must go up to infinity on both sides. So as I approach -1 from the right-hand side, I'm going up to infinity, and as I approach 3 from the left, the function values are going up towards infinity. Okay, if you remember, I said if in the denominator, so let's just look at x plus 1. This is to the first power, as is x minus 3 and x plus 3. So if these guys are only to the first power, then the function has to go to opposite infinities. So since the function is going up towards positive infinity on the left-hand side, the right-hand side must be down towards negative infinity. And then I'm going towards the x-axis because that is also my horizontal asymptote. Okay, good. So now at x is equal to -1, again, on the left-hand side, I'm already up here at positive infinity. So that means on the other side of -1, I must be down at negative infinity. And then at some point, I just turn around and come back because, again, I have to go towards negative infinity. I can't go up towards positive infinity without crossing the x-axis, right? So something like that is not possible. So let me erase that. Okay, good. And then again, over here on the left, because I already went down to negative infinity on the right-hand side of -3, on the left-hand side of -3, the function values must go up towards positive infinity. And then they, of course, go towards our horizontal asymptote as well. Okay, so again, there is nothing wrong with plugging in points to check. Okay, so let's, and remember, you're just checking to see if you get a positive value back or a negative value back. So we could plug in, for example, you could plug in 4 and just double check that when you look at f of 4, just double check that you're getting a negative value back. Okay, let's see, here we have -2. Double check that f of -2 is also going to give you a negative value back. Okay, let me put in a number simple, right? So a negative number here. Okay, that f of -2 should also be a negative number. Okay, so this one, let's work out this one. Okay, so f of -2, I have a -4 in the numerator. In the denominator, I'm going to look at the factored form because I think it'll be easier. I have -2 plus 1, so that's -1. -2 minus 3 is a -5, and then -2 plus 3 is +1. So I have a -4 in the numerator and 5 in the denominator. So we get the value -4 fifths. So that fits because my function value here is below the x-axis. Okay, from there we can't go across the x-axis because there's no x-intercepts. So both of these portions of the graph have to be going down towards those asymptotes. Okay, good. And then you could even do another one, -4 here, double check that f of -4 is in fact a positive number this time because the function value is above the x-axis. Okay, so here's the graph just with horizontal and vertical asymptotes. Okay, and again, I'll go through it one more time if you have any questions. Hopefully this will clear it up. The only point we had is 0.4. Okay, but this was actually enough to get us through the whole graph, right? So we have to go up towards both these asymptotes. Since I'm already going up towards infinity on the left, I must be down at -infinity on the right, and I have to go towards my horizontal asymptote. I have this section here that's in between my x-intercepts. Again, I've already gone up towards infinity, so I must be down towards -infinity on both sides. And then same thing here on the left. I must go up towards positive infinity because I've already gone to -infinity on the right-hand side of -3. All right, and here's the graph drawn on Desmos. Okay, good. That's it for the video number 2. In the next video, you will have your PowerPoint lecture questions to complete and turn in.